Okay, so we want to get back to forces and motion. What's different this year is that the force we're going to be looking at isn't necessarily applied in the direction of motion of the particle or the object. In year 12, we had horizontal forces that would move the particle horizontally, or we had vertical forces that would move the particle vertically. As you can see here, we have a diagonal force, but the particle, the object, the box on the ground, is going to move horizontally. So a diagonal force that generates horizontal movement. Okay, as you can see, we always want to make and start with our own diagram. There's lots of additions we'll make to this diagram. Firstly, I'm going to add the reaction force. There will always be a reaction force if there is weight going into a surface. And here I'm going to add the components. So this diagonal force has horizontal component to the right and a vertical component going up. Be sure to label the direction of these forces to be clear what we're doing with them later on. Okay, and I'm just going to annotate in the actual magnitude of these components, 10 sine 30 and 10 cosine 30. So using that quick trick we spoke about before, the opposite will always be a sine function and the adjacent will always be a cosine function. My diagram's complete. I can go ahead and resolve vertically. There are three vertical forces: the reaction force, the hg of the weight, and the vertical component of the force. So the two going up equal the one going down. R plus 10 sine 30 equals 8g. Rearrange to make R the subject, and we'll just punch it into our calculator. And at this point, a quick reminder, our calculator should be in degree mode. For applied, we always work in degrees. Don't worry about radians. So, punch that into the calculator, we get a reaction force of 73.4 newtons. All right, we were also asked in the question to go ahead and find the acceleration. I found the reaction force first. Let's go ahead and find that acceleration. We're going to think about the direction of motion. That's horizontal, and we'll resolve. So the resultant force is going to be F, and then we have our mass and acceleration. Resultant force in the positive direction, 10 cosine 30, and that equals the mass multiplied by the acceleration. The mass we know is 8, and the acceleration is the unknown we're looking for. Some quick rearranging, and we get an acceleration of 5 root 3 over 8. But as a decimal, we'll take that as 1.08 meters per second squared. Resolving vertically, resolving horizontally.